Hello everyone, welcome to this video. In this video, we are going to discuss about capacitor. Okay, so you're going to learn about the complete detail of the capacitor throughout the series. Okay, so first of all, we will discuss about what is capacitor. Okay, so previous video we already discussed about what is resistance. Okay, and in this video, it's completely for the capacitor. Okay, so first of all, capacitor is a two-terminal passive electronic component. That means so while we studied about the resistance, that is also the passive component, right? So while we study about this capacitor, it is also the passive component. So what is the purpose of this passive component? So the main thing of this passive component is it is not going to be generate any energy, okay? But it's the purpose only going to be storing the charges or limiting the current, okay? So in this resistor, we studied that it is going to be dropping some voltage and limiting some current. But in this case, capacitor is one of the electronic component which is going to be used for storing some charges. Okay, so that's what it is going to be. Capacitor is going to be used. Okay. And main important thing is the electronic components, it's for storing electrical energy, okay? Because whenever we are going to be storing a charges, that comes under the electrical energy. So we might be studying a lot of energy like kinetic energy, potential energy, chemical energy, nuclear energy, kind of many things. So when it is comes under the power, like your electrons, so when you want to be storing this kind of charges, which comes under the electrical energy, okay? That electrical energy is going to be formed as an electrical field in between the plates. Okay, so this detail you are going to be clearly understood, clearly going to be understand in this series. Okay, and if you see that, so yeah, so when I'm going to be connect one power supply to the capacitor, okay, you just consider this is your capacitor, and I'm trying to give some supply voltage, okay, positive and negative. So what will be happen? So when I'm going to be give some power supply, the capacitor will be started to storing some charges. Okay, taking some electrons and storing a charges. Okay, so that how it is actually going to be storing the charges, everything we are going to be detailedly study here. Okay, and this is how the capacitor will be looks like, and then we are going to be discuss about the construction. Okay, how it has been actually constructed. Okay, so capacitor, which is consist of first of all two conductive metal plates. Okay, so whenever we are going to be check it out this capacitor, so there is a two metal plates will be looks like this. Okay, so these two is called as in metal plates. Okay, and this is most commonly we call it as a metal plate. It is made up of aluminum, tantalum. So these kind of the components which is made up of this metal plates. Okay. You just consider this two is a metal plate in your capacitor. Okay. And then what about the insulator? Because the conductor material of the capacitance either in can be square, circular, rectangular, cylindrical kind of shape. Okay. So if you're going to be check it out this two, because we might be saw the capacitor symbol of this symbol, right? So which indicates these two are metal plates. Okay. But these two metal plates will be in different shape, either uh different shape of square, circle, rectangle. So we can able to see see in different shape. So it should be in the square shape, it should be in the rectangular shape, it should be in the cylindrical shape. So kind of different type of shapes will be available in this kind of metal plates. Okay. So these two called as in plates going to be storing a charges. This is plate one. This is considered going to be plate two. Okay, and it's fine. Okay, and in between, because these two are metal plates, okay, these two are metal plates, we know that how we are going to be actually give some charges. Okay, so we are going to be connected into the power supply, right? So we are going to be connected into the power supply, and these two terminal, these two, metal plate is going to be connected into the one end of the charges. Okay, another going to be connected in another end of the charger. So this is how it is going to be connected. Okay, for example, you are going to trying to give some power supply voltage. You are going to be trying to give. Okay, that for example, DC supply you are trying to give. Okay, so one is positive and negative. So this is called your complete DC power supply. And what is actually going to be happen? So definitely whenever we are going to be giving some voltage, how it is actually going to be performed. Okay, that's we are going to be discussing. So Whenever I'm trying to give some power supply to this metal plates, okay, two are same because two are metal plates. It is going to be conducting material. So when I'm going to be touching each other, so when I'm going to be bring it together, so both are easily get oxidized. Okay, you just consider one is positive and another one is a negative supply. So what will be happens? It will be easily get oxidized. The thing, right? So it will get waste. So which is not going to be touching each other. So for that, we are going to be bring up one insulating material in between these two metal plates. Okay, this is called as an insulating material. Okay, you just this one is going to be called it as an insulating material. Okay, also we call it as a dielectric component. Okay, so which is not going to be conducting anything. Okay, so same thing. So that dielectric material which is going to be act as an insulating material in between your plates. Okay, so this dielectric material it is going to be determined. Okay, so depends on the dielectric material we are going to be using. There is a lot of dielectric materials, common dielectric materials are there. For example, hair, ceramic, mica, paper, so plastic, electrolytic oxide. So because these are the component, these are the insulating material which is not going to be conducting. Mica, it's not going to be conducting. Plastic, which is not, because these are the component which is comes under the insulating material, right? So we are going to be choose that dielectric material is going to be differ. Some dielectric material which is going to be have the it is going to be performing the different capacitor properties. Okay, some of the dielectric materials which is having the high leakage current. Okay, we are not going to be choose that kind of one. Okay, high amount of leakaging current. So most of the current will be leaked. Okay, you can't able to store the charges properly. Okay, some of the thing which is having the high breakdown voltage, so you are going to be measure all those parameter and choose the dielectric material properly. Okay, and these are the dielectric, for example, materials. Okay, and how it is actually going to be looks like us. Yes, so this is how it is actually going to be looks like. So if you are going to be check it out here, these two are metal plates. Same, we are going to be drawn here, and these two are metal plates, and this is called as a dielectric component. That means insulating material. Okay, and most probably are going to be a symbol like this. So when I'm going to be giving the charges, the voltage, what will be happens? What will be happens? So we'll see it will completely study about this concept on here. Okay. So for example, if I'm trying to give some power supply, okay. So we know that the potential, so DC power source, this is a DC power source. Okay. So the electrons will be started to move from low potential to the high potential. Okay. The electrons will be started to move. Okay. At the time when the electrons are started to move to this direction, so what will be happens? So this is having the it is contains the more electrons will be present here. So these electrons will automatically get pushed the electrons. Okay. So when the electrons are started to flow to this direction. So we know that in every metal, okay, in my normal metal plates, so what will be happens? The free electrons will be there. Okay, so this is called as a metal plates. This is also your metal plates. So we know that just having the more free electrons will be there. Okay, so when those electrons is also going to be contributing here, you can able to see the more number of electrons will be available through this direction, right? So this concept is okay, fine. So these electrons will be trying to pull it. Okay, so charges will be present like this. So this plate which is contain more number of electrons is going to be representing there. Okay, so now you are going to be consider this position because this is also having some of the electrons will be available because this is having some free electrons. So previously it is also some free electrons has been available. So some of the free electrons is there. And when I'm going to be give some charges, this from this port, so some these electrons started to move from the lower potential. Okay, and these electrons started to replaced here. Okay, and this time it is having default electrons. Free electrons will be available in this plate. So this is positive charges, right? So this positive charges which automatically pull up this electrons. Okay, it is easily get oxidized. It is easily get neutral. Okay, at the time you can able to see the positivity get increased. The protons will be represent high because when I'm going to be or if you are going to be take if I'm going to be removing the electrons, okay, if I'm going to be removing the electrons in any metal, what will be there? Only the protons will be having a high amount. Okay, so when I'm going to be removing, when I'm going to be this electrons started to removing, which is pulled by this positive charges, what will be happens? So only the high amount of positive protons only going to be representing there. Okay, so in this time, it just contains the positive energy. It just contains the positive energy, and it is contain more negative energy. Okay, that means electrons. This is just contains the protons. So you just think it, both are get started to pushed. Okay, so these electrons will started to push this place. Okay, these electrons will be started to push, and here the protons will be started to push here. Okay, this time what will be happen? Okay, because of negative charges going to be pulled through this positive charges, the protons energy get increased. Okay, now you can able to see that positive energy and negative energy both are get started to push the dielectric material. Okay, this dielectric material in one side it is completely having positive charges, in other side it is completely having the negative charges. So when these two get hitting each other, so it will automatically create the electrostatic energy. Okay, we know that magnetic field, right? So whenever I'm going to bring the north and the north pole, so it is not going to be attract, it is going to be repel them each other. Okay, so when I'm going to be bring north and south pole, okay, what will be happen? It will be creating the magnetic field. Same when I'm going to be bring up this positive and negative together, it will be creating the electrostatic field. Okay, so this electrostatic going to be stored as an energy. Okay, it will be stored as an energy. Okay, so that's what we are going to be completely discussed here. Okay, and next one, formula for capacitance. Okay, if you want to be find it out, what is the formula for this? Capacitance. We know that resistance, how we are going to be find it out the resistance value, which is going to be used by Ohm's law. Okay. So whenever we give some voltage, depends on the electrons will be flow, the current will be pass. If you want to be limit some current and voltage, we are going to be introducing this resistance. For that, we are going to be using the ohmic concept, Ohm's law. Okay. In this case, okay, if you are going to be check this in this case, we will. So in this case, which is we are going to be find it out the capacitance value, right? So which is going to be find it out the capacitance value of this one. Okay. So I need to be find it out the capacity because there we find it out the resistivity. If I give some this amount of voltage, and if this amount of current is flowing, what is my resistivity or how much resistivity I'm going to be produced? Okay, but here how much capacity, that means how much voltage you have been given. Okay, first thing is how much voltage you have been given, at the same time how much amount of charges is get stored here. Okay, when you're going to be find it out these two value, you can easily find it out what is the capacity of this capacitor. Okay, so how much charges you have been given, and we are going to be divided by what is the volt. If you are giving a 5 volt, and if you are going to be store the charges up to 60 coulomb, because charges the unit having the 60 coulomb. Okay, and what you are going to be get, so you will get the value for 12. Okay, so for example, the capacitance level is 12 farad. Okay, the farad it is going to be considered as an farad. So this is a basic example. You're going to be understand how you're going to be calculating the thing. Okay, and yes, C is for capacitance, Q for charge going to be stored, and V for voltage across the plates. How much voltage has been across? Okay, and where the energy is actually gets stored. Okay, so this word, so we already discussed it, right? So where this actually gets stored means we often say, okay, charge is stored on the plates, but energy is actually stored in the electrostatic field in the dielectric between the plates. So what we actually mean here. Okay, so actually we are going to trying to give, wait a minute. Okay, so you just think it here, what is the, this is very important point guys, because charges are stored on the plates. So we often say, here I also sometime I use the word called as an charge. Okay, actually what actually it is going to be stored is, it is going to be stored as an energy. Okay, so energy is going to be stored as an electrostatic field in the dielectric material, because we are just producing the charges. We know that. So the electrons have started to move. The electrons which presents inside us, But even though we have given this electrons inside that, it is not exactly stored as in charges. It just stored as an electrostatic field, because here it just take the positive high number of protons. Here it just collecting the more number of electrons. Both are get pushed in between the dielectric material. It automatically create the what? Electrostatic field energy. Electrostatic energy. Okay, field or energy can tell. Okay, so you should call it as an electrostatic field. Okay, and in between the dielectric plates. Okay, when it is get charged, what will be happens? When it is discharged, what will be happen? Okay, when you're going to be charged this, the current flow into the capacitor at the time the electrostatic between the plates gets stronger as more energy is going to be stored. Okay, so whenever you're giving a charges, the time the electrostatic field get more at the time it is get stronger, because you can capable to store high amount of capacitor level. Okay, more amount of field you're going to be trying to store at the time it get more energy. Okay, when you're going to be discharge the thing, current flows out of the capacitor. Okay, it will be started to discharge the charges. The voltage between the plates get automatically get drops. Okay, so when I'm going to be take off the voltage, what will be happens? The voltage drop will be happens at the time the charges is get discharged. Okay, it is not going to, these electrons and protons is not actually going to be pulled, not actually going to be pushed the material. So automatically charges get discharged. Okay. And yes, so electrostatic field automatically get peaks, the energy automatically get leaves. Okay. So, and what are the two key capacitor properties? So capacitance mean ability to store charges in the electrostatic field. Okay. So we can able to store the charges as you are going to be given on the mind electrostatic field. Okay. Okay, so this point is very, very important and short. So what you're going to be understand from this concept is a bigger plate. So when you're going to be using a big plates, okay, you can able to see more amount of electrons and protons will be accumulated at the time. Small gap. Okay, so you can able to push the complete dielectric. So at the time, only small gap will be there. So you can able to see more amount of capacitance level will be there. So when you're going to be using a bigger plates, more capacitance, get smaller gaps, so more capacitance. So how much charges you're actually storing per voltage, that is going to be considered as capacitance. Okay. Energy is always stored as an electrostatic field, not as in complete electrons. Okay. So capacitance smoothing the things, and voltage changes because of the ability to store and releasing the charges quickly. It's not always when you're going to be giving the voltage, okay, so it will be store the charges. When you're going to be take off the voltage, it is automatically removing. Okay, unit we are going to be using farad. Okay, when how we are going to be calculating the capacitance values depends on farad. So how much charges divided by voltage you have been given. Capacitance, how much charges for a capacitance for per volt. Okay, so it is going to be measured by farads. Okay, so what are the farad is there? So microfarad, nanofarad. So we are going to be considered as a microfarad and nanofarad and a picofarad. Okay, so these are the minute capacitance value. Okay, and yes, so these are the thing. Okay, so I hope you got clear about this one. So next video we will discuss about the what are the kinds of capacitor, different types of capacitor, and what is the difference between DC and AC circuit. So see you on next video. Until it's goodbye from Chalet. Bye guys.